Welcome to another problem session. So this is an interesting problem um, of two-body system. So when you have there are two stars. There is a star here, mass m1, and there is a star here, mass m2, and this one has been accreting mass from this one while this guy is going in orbit. Of course, this system, two-body system, you can do dirty work here, or a little more. You can do dirty work here, or do a little more systematic. Let me do it over here. So, how do you handle this kind of situation? Depends on how accurate you want to get. So they have a couple of things that are saying that M1 is much bigger than M2, much bigger. So it's kind of like a sun, almost like a sun type of system, Earth system, sort of. So that kind of says M1 is much greater than M2. So you can go right away there, and you can work with that, or you can say two-body system. You're going to say, hey, don't worry about the masses. Here is the separated distance. Center of mass will be somewhere here. So the two-body system will be if I go in the so center of mass, so total mass m1 plus m2 moves with cm, and this guy is going around in his smaller orbit, and this guy is going around in a bigger orbit about the cm. Okay, so but both of them are going on cm, so both of them making orbits. Okay, but that really is not necessary for this problem, because we have just this. However, you were going to go there, how would you do? So you have one set of equations like that. Another is relative from 1 to 2, relative vector r, relative distance r. So this vector r will actually motion of a reduced mass mu at displacement r. So you can imagine a new system. You have an origin, and you place a mass mu, and then it has a force. So force on mu is central force. Force on mu is just minus g m, and you put an entire mass here, don't make it move, over r square, and say this distance is this direction is u hat, unit vector u hat, then you need opposite direction. with a negative sign there. So you solve this problem. Which is when you reduce this is this problem. So instead of that, what's the reduced mass? If you look at reduced mass, mu is m1 m2 by m1 plus m2. That's called reduced mass. And if m1 is much less than m2, then I get numerator remains the same, but denominator just becomes m1, cancel m2. So when we are here, we have this system m2 O, and all the mass is placed here. So this guy is it just becomes a motion of just this, motion just m2. And in the problem it's saying that further simplification, if you do, it's going to be orbit will be elliptical orbit. So it will be elliptical orbit. But here it's saying something more. It's saying that, well, what's going on here is a circular orbit. Just take it circular orbit. Okay. So, and take this guy. If total m is m, so this is just m1. So just take a circular orbit and don't even worry about motion of this star. Okay. So that's what they're saying. But this is very simple. So suppose that time t is over here and some instant t. So we can write the equation motion just like this. And it's moving at a speed v. So mv square, and then it's at a distance, orbit is r at this, and which is a time dependent. This m2, this is time dependent, this is time dependent, is equal to if this acceleration is pointed in that direction and the force is pointed that direction, so I don't need to include minus g m1 m2 r square. So this one equation we're going to get, which will get its motion. Also, because this is a central force, over here the angular momentum is conserved. This guy's mass may be changing, this guy's mass may be changing, but together they are because it's not going anywhere, so no angular momentum this guy, so this guy's angular momentum remains the same with time. So angular momentum will be angular momentum L is r cross p, and it's going to be perpendicular to this. So if you look at just the magnitude, and because this is the r vector and v vector is that way, and this 90 degrees between them, so it just becomes mvr. This is time dependent, this is m2, this time dependent, this time dependent, this time dependent. So here, because so you have a m2 t vt rt is constant, some constant. What we're supposed to do is find how the orbit will change with time. So this r will not remain the same. It might go up, it might come down. You have to find it what's like that. Okay, so it seems like I can convert everything in using this. We can get rid of v in terms in favor of keeping r. So this will, we can process a little bit. M2 cancels out on both sides. So this M1 is time, this is time. So keep track of the time. I'm not going to keep writing it, I just keep in mind. So V square equals to GM1 over R. Okay, so V equals to square root. So V equals to square root of this. I put in here. So I have M2 and then R square root G square root M1 over square root R. That's equal to constant. Let's absorb this constant in here. This is also some constant K. And so this becomes a square root over here. Okay, so I've got M2 square root R square root M1, some constant K. And now we have to, from here, given d1 m1 dt is gamma, m1 is increasing in mass, dm2 dt equals minus gamma. So these are given to us, so the same rate of the increase. We're supposed to find from here to find 1 over r dr dt in terms of all of this. Okay, this is a product of everything, so this is a product expression. You could take a log, or you can just do straightforward. So let's do straightforward. Let's just do, I would do log and then just take a derivative, hit that with derivative. So this will be first for m2, I just get a dm2 dt and then we have a square root of r square root of m1 plus we're going to get 1 over 2 square root r dr dt m2 square root of m1 plus we're going to get m2 square root of r 1 over 2 square root of m1 d1 dt. On the other side will gives dk over dt, which will be 0. It's constant. Okay, so it looks pretty complicated, but if I divide by this term, each one of them, if I divide this by m2 square root of r square root of m1, same thing over here, m2 square root of r square root of m1, m2 square root of r square root of m1. You'll see it's going to simplify. These guys all go away. Square root of m1 goes away. This m2 goes away. M2 goes away. Square root of r goes away. So what do I get? And then we can use this guy is going to be minus gamma, and this guy will be gamma. So we got minus gamma over m2. Okay, right? Minus gamma over m2 plus 1 over 2. This square root of r square multiply, this gives me r dr over dt Then I have a gamma over 2m1. Now it's really, if you compare, of course over here is what I want. Let's separate it out. So 1 over r dr dt, what we want. So this gamma over m2 goes over there, and minus gamma over 2m1 comes here. All right. Now you can, at this point, you can see if one of these terms actually much bigger, because we don't want to have both m1 and m2. So we have m1 much greater than m2. Then 1 over m1 will be much less than m2. Of course, 1 over 2m1, even half of that, will be even much less than m2. Oh, 1 over m2. Of course, you multiply by gamma over 2m1, much less than gamma over m2. So using the same level of approximation, we see that this guy is negligible. We can drop it off. So this just becomes 1 over r. Oh, did I not multiply by 2? So I should have multiplied by 2 here and 2 here. So I would have just 1 over m1, 2 over m2. So we didn't need to go here. Oh, just do gamma here and gamma here. So what we left is 2 gamma over m2. So that's the answer. Now, do we have an answer here? Actually, our answer is 2 gamma over m2. So they're all minus. So first we have an answer plus. So it's actually, if this was a plus, this would have been answer. So none of these. Okay, so the choice none is correct. And as it turns out, when the posterior solution, it marked B, that was correct. But that's not correct. We have this as an answer. We can trace it down. Did we mess up any place? So let's just repeat, make sure that we haven't messed up. So over here, when you come to a conclusion which is not, so it's coming from this, right? M2, so let's do it over here. We have M2 is square root of M1 square root R equal to 0, constant. Let's hit with log this time. Log M2 plus half log M1 plus half log R is some other constant C prime, which is log C. So don't need, this is another constant, okay? Now take a derivative. So dt d log, oh, I already d log remembering from last time, that's always happens. So not yet complete. So this log, just I'm going to do ddt of everything, and then this one will be 1 over m2 d of m2 dt plus 1 over 2 m1 d of m1 dt 1 over 2r dr dt. That's 0. So separate this out. 1 over r dr dt 2 times those guys, and on the other side becomes minus 2 over m2 1 over m1. Right, now m1 at time t is going up. That means dm1 dt is plus gamma. m2 at time is going down, so dm2 over dt must be minus gamma. So this will become minus minus plus 2 gamma over m2. It will remain minus 1 over m2 gamma, I mean m1 gamma. And clearly this is much less than that guy, so that will drop out. So this is plus 2 gamma over m2, so that's a plus, not minus. So I kind of did that again, and so none of these is correct. So it happens. Sometimes there is some mistake somewhere. All right, so we'll see you in another video. Okay, bye.